right, so I had somebody ask about a couple questions with doing the derivative and trying to figure some things out after we get the derivative. So this is question 6, where we have f of x equals 5ax cubed minus 2bx squared plus 4cx, and I want to take the derivative of that. So multiply and subtract 1 from the power. So we get this as our derivative. And that was, pretty straightforward on f prime of x. But then part B asks this interesting question that it says f prime of x is greater than or equal to 0 and a is greater than 0. And we're supposed to show that b squared has to be less than or equal to 15ac. And so this is confusing here. So what I'm going to do is I'm going to take my original derivative here and say it's greater than or equal to 0, because that's my assumption right here. And if it's greater than or equal to 0 for all x values, what I've got then is I've got a parabola. And I know the parabola opens up because the a value is positive here. And if it's greater than or equal to 0, I know that my parabola can touch at one point at its vertex, or maybe it doesn't touch at any point there. And so then what I can say is that the vertex of a parabola is at where x equals negative b over 2a. And I put quotes around that because the b over 2a there comes from your standard form of a quadratic equation. It's not the same b and a that are in our values right there. And so what I can do then is identify here is like our b value, and here is like our a value. And so I can actually find the vertex of the f prime of x here. So f prime of that lowest value right there is going to be when I plug in negative b over 2a. So I'm going to plug in positive 4b, because that's the negative of my quote b, over 2a over 30a, like this. And we'll see what pops out here. 15a times the input squared minus 4b times the input plus 4c greater than or equal to 0. And let's just see what ends up happening here. So I get 15a times 16b squared over 30 squared a squared minus 16b squared over 30 plus 4c is greater than or equal to 0. Let's try to do some simplification before we get going too much crazier here. Okay, so if I simplify, let's see, 15 times 2 is 30. So what I can do here is cancel an a with an a, make this 8b squared over 30, because I borrowed the 15 and a 2 from the 16 to make 30 and canceled one of the 30s. So I have 8b squared over 30 minus 16b squared over 30 greater than or equal to, I'm going to do plus 4c greater than or equal to 0. Then this should say 30 on the bottom. I'm going to multiply. Now I'm going to reduce my fractions here. So, and I can combine them because they have a common denominator. So I can make this 4b squared minus 8b squared. So that's negative 4b squared over 15. I just reduced my fractions. Plus 4c greater than or equal to 0. That's the same as 4c greater than or equal to 4b squared over 15. Oh, sorry, I lost my a. Let's go back and fix that. I lost my a. This should have an a here. So then this here needs an a. Now, and so then I've got the a right there. And then I can multiply both sides by 15a and divide both sides by 4. And I've got the expression that I wanted. 4ca is greater than, 15ca is greater than or equal to b squared, which is the same as what I was asked to prove right there. So the key thing on this problem is to see that your derivative is a quadratic, so it's in the shape of a parabola, and that if it's greater than or equal to 0, what you know is that its minimum value is greater than or equal to 0. And so that's why I plugged in the minimum value of the function and said that that also was greater than or equal to 0. Okay, so there we go. That's that problem. Kind of some nasty algebra there. I should have really done that a lot cleaner. But please comment or ask questions if anything was confusing or if I made any mistakes. Thanks.